Hey, how you doing, superhumans? Welcome back to our new lecture. And in this lecture, we will be covering in detail about another type of ICMP message, that is redirection. Now, before moving on further, I would like you to focus upon this great quote that I have written on the board, that is, discover the greatness that resides inside you and make sure that you use that greatness to its utmost capability. The greatness lies inside you. Remember that. Okay, now let's get back to our topic about the redirection and let's understand when is the redirection method sent. So let's say that there's a packet that sender S, this is the case A, this is that the sender S is sending to the destination D, and the route that sender S has taken is this one. Now, this is the IP packet. The IP packet reaches over this route, or we can say that when the IP packet reaches the router R1 finds that there could be a better route as well to send the packet. The better route could have been if the sender S would have sent the IP packet directly to the R4, then it would be more cheaper in terms of a lot of things. Cheaper in the sense that it would have taken a lot less number of resources, and also the network congestion would be very less. And there are a lot of other things based on which I am telling that it's cheap, not the financial way of cheap, but the cheap on a lot of different factors. Now, what would happen is this router R1 is although going to forward this IP packet further to the complete route so that the packet reaches the destination. But why, when it forwarded the packet IP1, it is sending back an ICMP message of type redirection, telling the source S that you should be redirecting the IP packet the next time you send the IP packet to the same destination D, that there is a better route to send the packet whenever you are sending to the destination D. Okay, now this ICMP message will also contain the data of updating the routing table. Updating the routing table of sender S. Because when sender S initially had sent this the first time, when sender S sent this IP packet, IP1 packet to the resource to the router R1, in its routing table, in sender S routing table, according to sender S, the best route was this, that first R1, then R2, then R3. But the moment the packet reaches the router R1 sees that there could be a better way. R1 judges that based on its own routing table. This is one of the methods through which the router R1 judges that there could be a better way to send the IP packet. And when it finds that there could be a better way, the router R1 is simply going to send an ICMP redirection type message to the sender S telling that update your routing table with the better route. The better route is R4 and then D. Now you must be asking this thing, that why hasn't the sender S updated the routing table of itself on its own? So the answer to that simple question is that senders are hosts, and the routing table of hosts is static. This is the reason behind this is that there are a lot of hosts in the network, and the routers are comparatively lesser amount. So the dynamic table, I missed the point that I should have said routing table. The routing tables of the hosts are therefore static. Okay, and the routing tables of the routers are mostly, this is in general I am talking about, not, it might be the case that some of the hosts are not having the static routing tables, they might be having dynamic, but generally we see that most of the hosts are having static routing tables and most of the routers are having dynamic routing tables. So since they are having static routing tables, so the route that the sender S tells is the static route, or the route that the sender S gives to the packet IP is the static route. Okay, next, let's take the case B. Over here, let's say that the sender S has sent the packet IP again. I mean, not again, it's the second case that the sender S is sending the IP packet. Okay, the moment this IP packet reaches R1, although it is going to forward, the sender S had sent the route as S, R1, R2, R3 and D. This was a route that was given by the sender S for the packet to send the packet to the destination D. Now, the moment this packet IP reaches the router R1 and it sees that the sender has written this route, this static route in the packet, then it sees that it checks its routing table, router R1 checks its routing table and it finds that there could be a better route to send the IP packet. And what it does is, instead of following this route, it sends the packet through our R4, and the moment it sends the packet through R4, it tells the sender that I have redirected your packet. It sends an ICMP message of type redirection to the sender, telling him that I have redirected the packet through the router R4, and that the better route for sending the packet was S, R1, R4 and then D. When router R1 in its ICMP redirection message tells the sender S that the better route to route these packets, to route the IP packet was this, then sender S updates its routing table. I hope that up till this point would have been very much clear to you. Now there are a few mistakes that a lot of students do, and this is a technical question, conceptual question. As you might have seen over here, that router R1 is not discarding the packet. What it is simply doing, it is simply forwarding the packet, but it sends the redirection message to the sender S to tell him that you need to update your routing table with the better route. Okay. Over here as well, router R1 has not discarded the packet. It has made sure that the packet moves forward. Instead of discarding and then sending the ICMP message, what it does is it forwards the message and then sends the ICMP message back to the sender S, telling him that update your routing table with a better route. Now, there are a few points that you need to remember over here. Those points are that ICMP message of redirection ICMP message is of type 5, and the codes can be 0, 1, 2 and 3, where code 0 means that the redirection is for a specific network route. For example, if I think that these are pretty complex terms that you do not need to go deep dive inside. So this all you need to remember it, and these are self-explanatory, that this redirection message is for a host specific route. I mean, let me just tell you, network specific route is when the packet, let's say this is the sender, this is the final destination, and these are the routers in between, and this is the network. Okay, network specific means it is redirecting the message to a particular network. Host specific means it is redirecting the message to a particular host that is helping the packet to reach that particular host only. But when it is a network specific route, it specifically means that we are redirecting the message to a particular network. From that particular network, the message will go to the destination. Now, code 2 basically means redirecting the packet through a network specific route, but also based on a special service type. Code 3 means the same as code 1, but there is a certain more functionality to it, and that functionality is redirecting the message through a specific host, through a host specific route, and making sure that there is a special service type. Now the third point is that I have already explained to you, that ICMP message, in ICMP message where the type is redirection, the packets are not discarded. Packets are moved forward. Packets are forwarded. But an ICMP message of redirection type is sent to the sender S telling the sender S to update their routing table with a better route. I hope that this would be very clear to you. Bye.